Tonight in Arkansas, there's a mother tucking in her daughter and turning off the light. A business owner is burning the midnight oil. An at-home dinner date is plating up possibility. And it's all happening under one roof. How? The power of a conversation, like the one John from Integrity Solutions had with First Horizon Bank about his vision for a sustainable mixed-use building. Now it's not just words, it's life. First Horizon Bank. Let's find a way. Go to firsthorizon.com/John. First Horizon Bank, member FDIC.
Hello again, and thanks for joining us on Astronomy Daily. And coming up on this edition, we're going to be looking at a few landmark pieces of science, particularly about a breakthrough in the provision of power going forward. We're talking about fusion, which is quite an extraordinary discovery if it holds true. And we're also going to look at another breakthrough in science, that of making light travel in two directions in time. There's an experiment that's been done on that. And we're going to take another look at impact craters on the moon because they've come up with a new theory about how some of them were formed. That's all coming up on this edition of Astronomy Daily.
Astronomy Daily, the podcast, with your host, Andrew Dunkley.
But before we get into all that, we say hello to our AI reporter, Hallie. Hi, Hallie. What have you been up to?
Hi, Andrew. I've been trying to understand humans better and realized that you do a lot of talking about things that aren't necessarily important or are inconsequential.
Yes, that would probably be accurate.
So, how are you and what about that weather, huh?
You're getting the hang of it, Hallie. Let's get the news.
Scientists have managed to simulate their very own black hole in their lab and witnessed how it began to glow. The Black Hole Event Horizon was created by a team of physicists from the University of Amsterdam, who used a chain of atoms in a single file to gain further understanding about the behavior of a black hole. Its creation managed to prove Stephen Hawking's theory from 1974, where the black hole emitted a rare form of radiation. They studied the properties of Hawking radiation through the creation of a black hole analog in the lab. According to Science Alert, Hawking radiation happens when particles born from disturbances in the quantum fluctuations caused by the black hole's break in spacetime. The fake black hole event also caused a rise in temperature that matched theoretical expectations of an equivalent black hole system. The first of 6 new generation weather satellites is set top launch this week as a part of Europe's €4.3 billion Mediasat, third generation, or MTG, program. The first satellite will head for a position in geostationary orbit more than 22,000 miles, nearly 36,000 kilometers, over the equator to begin a planned 8.5-year service life. It carries a rapid scan imaging instrument, a lightning detector, and radios to support search and rescue services. The spacecraft will be renamed Mediasat 12 after it enters service next year, becoming the primary source of satellite weather observations for real-time forecasting in Europe and Africa. The MTG program is a partnership between the European Space Agency and EUMETSAT, Europe's weather satellite agency with 30 member states. Mirosław Hermaszewski, who was the first, and to date, only citizen of Poland to fly into space, has died at the age of 81. Hermaszewski's death on Monday was confirmed by his son-in-law, Ryszard Czarnecki, a member of the European Parliament, in a post on Twitter. As a pilot in the Polish Air Force, Hermaszewski was selected as one of 500 candidates to potentially become his country's first spaceman, only he did not know it at the time. Initially kept in the dark about what he and his fellow pilots were being tested for, it was not until the group was narrowed did Hermaszewski learn where the process was leading. After 2 years of basic training at the Yuri Gagarin Cosmonaut Training Center in Star City, Russia, Hermaszewski was assigned to fly with Soviet cosmonaut Pyotr Klimuk on Soyuz 30, an 8-day mission to the Salyut 6 space station. And that's it for news today, Andrew.
Thank you, Hallie. We'll catch up with you before the end of the show. Now, in other news of astronomy and space science, US researchers announced a historic nuclear fusion breakthrough this week. They've hailed a landmark achievement has been set in the quest for a source of unlimited clean power and an end to the reliance on fossil fuels. The Lawrence Livermore National Laboratory in California said an experiment was conducted this month and produced more energy from fusion than the laser energy used to fuel it, which is an extraordinary claim. The US Department of Energy described the achievement of fusion ignition as a major scientific breakthrough that will lead to achievements in national defence and the future of clean power, I think the latter being more important. LLNL Director Kim Buddle described it as one of the most significant scientific challenges ever tackled by humanity. Quite an amazing claim, and one that could have massive repercussions for the future of energy and so many other things in the future of humanity on this planet, while we try to tackle greenhouse and global warming problems and our reliance on fossil fuels. Now to another scientific breakthrough. For the first time, physicists have made light appear to move simultaneously forward and backward in time. The new technique could help scientists improve quantum computing and understand quantum gravity. By splitting a photon, or a packet of light, using a special optical crystal, two independent teams of physicists have achieved what they describe as a quantum time flip, where a photon exists both forward and backward in terms of its time state. The effect results from the convergence of two strange principles of quantum mechanics, the counterintuitive rules that govern the behaviour of the very small. The first principle, quantum superposition, enables minuscule particles to exist in many different states or different versions of themselves at once until they are observed. The second, charge parity, the time reversal symmetry, states that any system containing particles will obey the same physical laws even if the particle charges, spatial coordinates and movements through time are flipped as if through a mirror. And by combining the two principles, the physicists produced a photon that appears to simultaneously travel along and against the arrow of time. Wow, it could mean a hell of a lot in future computing. They published their results on the twin experiments on the preprint server Arxiv, meaning the findings are yet to be peer-reviewed. But hey, it could make getting back that email you didn't mean to send a hell of a lot easier in future.
The Astronomy Daily Podcast
with Andrew Dunkley.
The moon, as we know, is fairly pockmarked. Looks like a teenager going through a radical change of life. And the history of the sphere has certainly been told by what's happened to it over its life. It's marked by over 9,000 impact craters, according to the International Astronomical Union. Now, the largest ones are not called craters, they're called basins. According to a new study, asteroids did not create the basins. Leftover planetesimals did. Basins are not only larger than craters, they're also more complex and tend to have a central peak ring rather than a single central peak. Features larger than 300 kilometres are called lunar impact basins, and there are about 50 of those. And the largest one is around the South Pole at Aitken Basin. It's 2,494.5 kilometres in diameter. That's 1,550 miles, and you could fit Texas in it. A new study says the leftover terrestrial planetesimals formed these basins when they slammed into the moon. The study is called Formation of Lunar Basins from Impacts of Leftover Planetesimals, published in the astronomical journal Letters. The lead author is David Nesvorny from the Southwest Research Institute. Previous research showed that asteroids from the main belt are responsible for these impact basins, but in their paper, the authors say that most impactors were instead rocky planetesimals left at 0.5 to 1.5 AU after the terrestrial planet accretion. And finally, the Herschel Museum of Astronomy in Bath in the UK has bought a new addition to its collection. It's a handwritten manuscript by Caroline Herschel in her own handwriting. The 57-page document represents Caroline's life in her own words and is said to be a very important addition to the museum because many of her scientific achievements were overshadowed by her brother William Herschel. It gives a unique look into the personal and professional life of one of Britain's most significant contributors to astronomy and someone who is considered a pioneer for women in science. The 2-chapter memoir titled The Memoir and Correspondence of Caroline Herschel was first published in 1876. Now, of course, if you'd like to chase up those stories, don't forget to visit our website, astronomydaily.io, and you'll find all those stories and more there. The stories rotate fairly rapidly, so if you do want to chase them up, get in there quick, because as new ones come in, the old ones drop off. That's the way it works. But there is a little button down the bottom. If you click more, it'll load more stories, so bear that in mind. You can also chase up the latest edition of Space Nuts. It's an all questions episode this week, episode 335, so look for that on your favourite podcasting platform. Now, before we go, anything else from you, Hallie?
Yes, Andrew. I've got an astronomy Christmas joke for you.
Oh, that's a rare combination. Fire away.
What do you get when you cross Santa Claus with a spaceship?
I don't know. What do you get when you cross Santa Claus with a spaceship?
A UF ho ho ho.
You know, that's pretty good, but you're still laughing at your own jokes. Bye, Hallie.
Bye.
Until next time, this is Andrew Dunkley for Astronomy Daily. Astronomy Daily, the podcast, with your host, Andrew Dunkley.